Perfect. So I'm going to share this. We're going to be, as part of going through this webinar, we have time for Q&As at the end of this webinar. I'm going to try and field questions. If there's certain questions that are directly related to a particular slide, I'll interrupt Chris and ask the question at that moment in time. But if it's not, I'll keep it till the end, and then we can have a more robust Q&A discussion time period as well. So I'm going to introduce Chris. Thank you so much for joining us. And thank you so much for all the work you've been doing on advancing embodied carbon understanding, but also more importantly, advancing providing the information to decision makers so that they can do a better job of bringing embodied carbon into their overall decision making. And I really want to thank you for all the amazing work you've been doing on that. And we're really glad to be working with you to try and take it to the next step. So I'll turn it over to you and say, take it away, Chris.
Great. Yeah, thanks. Thanks, Gabby, for the invitation and for everybody who's joining in today. I really do appreciate it. This is a sort of topic that has been a place for real sort of climate and building nerds for quite a while, and is starting to make its way more into the mainstream of the construction industry. And I really do appreciate everybody's interest here in the topic. So by way of introduction to this report, over the last year, the organization I work for, Builders for Climate Action, has been working closely with Natural Resources Canada, NRCan, on two projects so far. One, we helped them build an estimating tool for material carbon emissions in residential buildings. And then we used that tool that we developed to perform this study that I'm going to sort of take you through right now. And the notion at NRCan was they wanted to be able to understand the extent of what material carbon emissions contribute to the overall carbon footprint of a home, and then be able to think about what they may be able to do to intervene and reduce this side of the emissions puzzle too. So I know that buildings. I've been in the building industry for 25 years, and myself and so many other people have put a whole lot of time and effort into trying to reduce the operational carbon footprint of buildings at all scales and with all kinds of interventions and new buildings and renovations and all kinds of ways to reduce that very important part of the emissions footprint of a building. But the work that I'm doing now is really examining the impacts found in the sort of creation of the building materials in the first place, and looking at how big a piece of the overall carbon footprint of a building does that represent, and then sort of what can we do about it. And what's interesting is that little slice of the overall emissions pie, if we can call it a pie and divide it up that way, the vast majority of these impacts for the whole life cycle of any building material happen here at the product phase. So depends on the product, but typically somewhere between 70 to 85% of all the emissions that product will be responsible for over its entire life. So including transportation and installation and maintenance and disposal, this big chunk happens right up front here. And in life cycle assessment, this is phases A1 to A3, so raw material supply, transport, and manufacturing. And this is often called cradle to gate analysis. So right now we're not looking at what it took to get the material from the factory to a job site or the emissions associated with actually installing that material. When I have looked at that in depth, those two factors have been much smaller than the cradle to gate phase. And so, not to say that they're not important, but in terms of the impact that we can have, the lion's share of that exists here in that cradle to gate phase. And this kind of research has only really been possible in the last about 5 years, as more and more building product manufacturers make environmental product declarations. And they are an ISO standardized way of both putting a boundary around what you measure when you look at the impacts of a building material, and then the sort of rules for doing that in different product categories. And these reports look at actually 7 different types of impact, but we're really just looking at the global warming potential. So at the, in the end, one of the things an EPD does is say, for a certain amount of this material, this is the global warming potential of that particular material. And so what we've done with Enercan is make this material carbon emissions estimator tool. They're calling it MCE squared, and it's an Excel-based program where you can sort of put the parameters of your building into the calculator, and then select the materials that you're going to use for the building, or that if it's an already finished project, the materials that were used, and you sort of get a carbon footprint analysis of that building. And it also uses Enercan's HOT 2000 energy modeling software, so you can sort of import the energy model from the building, so you kind of already know what the operational emissions profile of that building looks like. And then in this tool, you add the materials piece, and then you can sort of get a picture of what the overall carbon footprint of that building is going to look like. So I'm going to sort of dive into some of the results from the study. We looked at in the study 5 different regions in Canada, and Toronto was one of them. So I'm focusing specifically on the Toronto results. Obviously, things differ depending on climate zone and codes and things like that. So we looked at a tier 3, tier 4, and 5 from the energy code versions of 3 different kinds of houses: a bungalow, a 2-story, and the end unit of a row house. So I'm just going to focus here on the 2-story, but the rest of the housing types kind of followed the same trajectory here. And so from the operational side, what we saw was that a tier 3, which is basically today's code minimum for energy efficiency, 2-story home in Toronto using natural gas for heating and hot water, had about 3.5 tons of emissions per year associated with those operations. And therefore, over a space of 20 years, a 70-ton carbon footprint for that building at tier 3. If we take the same building and move it up to tier 4, which is the highest tier you can go to in the energy code with natural gas as the heating system, we drop that to 2.7 tons per year, or 54 tons over the 20 years. So, you can see moving a building along and making it more energy efficient does have what you would expect, some intended result. But what happened was, when we looked at the same building with the same level of energy efficiency, but in its all-electric form using an air source heat pump for the heating system, the carbon footprint of these operations dropped dramatically, so that even at tier 3, even at just a code, like a regular code minimum building, it was down to under a ton per year. It was 0.71 tons per year, or 14.2 tons over the course of 20 years. So without making the building more energy efficient, just the fuel switch in Ontario made a huge difference to the carbon footprint. And if we move that building up the code, sorry, I think my slides might be in the wrong order. Oh, no, I am missing a slide. My apologies. When we move that building up the code to tier 5, it drops it to 0.44 tons per year, or 8.8 tons over the 20 years. So you can see, there's 2 things that we can see here. One is the fuel source makes a huge difference. If we can get our buildings off fossil fuels and onto clean electricity, there's a massive drop in emissions there. And also that, moving the buildings to be more energy efficient also has the positive impact that we would want. But what hasn't been factored in until we started doing this study is what is up here? What are these emissions from the materials for the building because that will be carried with the footprint of the building as well. So, we've typically just thought about the N number here for operations as what the building is contributing to climate change, but without knowing, where it starts, we don't really know what the total impact is on the climate. And so the results from the study are pretty stunning. If we take that same two-story building and use a set of materials that would be in every category, sort of the highest emission materials, that two-story house has 138.9 tons of emissions associated with making the materials. So, if we've solved this part on the right for operations and gotten that down to the 8.8 tons over 20 years, that's great. When we look at how much the materials could be impacting that building, it's huge. So in this worst case scenario, and the worst case scenario is not an unusual building to be built. So it's not this isn't a sort of, crazy version of a residential building in Ontario, that the material carbon emissions are equivalent to 315 years of operating emissions. So in other words, doesn't matter how energy efficient we make the building, if it has this kind of emissions profile from its materials, this is all the impact. In the window that we have to deal with climate change, means everything, and the operating emissions mean a lot less. So this was the worst case scenario. Now the scale sort of changed here, but because the first one was so high. But if we use a more sort of like moderate, sort of mid-range selection of materials for this house, and this one represents, the way quite a few buildings would be built in this region, that initial material carbon footprint comes down to 31 tons on the material side, and obviously the emissions for operations stay the same. So this building now has a 40-ton carbon footprint over 20 years, but again, 3/4 of that is right up here up front in the materials. And so it's going to take 71 years before the operating emissions are the equivalent of these material emissions. So, the worst case scenario is terrible, but even the sort of mid-range scenario is not great. It still really puts a lot of weight on the material emissions as the lion's share of what the building's responsible for in terms of its carbon footprint. Now, the next one here is really interesting. So we made a model of the same building, and we used the materials that had the lowest carbon footprint, that are code compliant and widely available in the market today. And what's really interesting is suddenly the material profile is actually a negative number. I'm going to explain that in a bit more depth later, but essentially what's happening here is that this building is using mostly insulation materials, but some interior finished materials as well that have net carbon storage. So they're plant and fiber-based materials where the carbon drawdown that plant had in growing outweighs the emissions that happen when that was turned into a building material. And so it sort of carries this negative carbon footprint. And so this result to me was extremely exciting, because this is the profile of a building that any builder in Ontario could be building today. These are all materials that are affordable, accessible. Everything is sort of there to achieve this kind of result in a building, in a house right now today. And so what's interesting here is that the materials are sort of 20 tons of net storage. So when we add the 8.8 tons of operational emissions at the end of 20 years, the net footprint of this building is less than zero. This is now actually a climate drawdown building. This is, doing the thing that everybody's wondering, how are we going to do the thing where we get carbon out of the atmosphere, not just, reduce emissions, but bring them down below zero. And here's an example of a model building that can do just that. And then if we take it sort of one step further, so yeah, this building is going to be net carbon storing when we take into account the storage in the materials and then the emissions from its operation for 45 years. So, that gets this building out of the way of causing any climate issues, over the span of time that we really need to deal with climate change. And that's a hugely encouraging result. And here's a more encouraging result, which is if we took materials that are the best possible materials for carbon footprint. So these are all materials that people have built code-approved buildings with in Ontario, but they're not common materials and they're not all code-approved. Some of these materials require alternative compliance pathways for a builder to be able to use them. But the situation gets even better here, where this building is now responsible for storing 83 tons of carbon up front. And that means that in 20 years, it's still a net 75-ish ton building in terms of carbon storage. And this will continue to be carbon storing for almost 200 years. And, it's hard to imagine a result this positive as we're sort of figuring out, what do we do about the climate? Here is one of the really sort of major answers about, what we could do, what we could be doing to improve the climate. So those were all based on sort of model buildings from NRCan's they have typical housing typologies, and they kind of use these three models of a bungalow, a two-story, and a row house. Right now, we're working on a very similar study, thanks to a grant from the Atmospheric Fund and our partners at Passive Buildings Canada. We're looking at 100 homes in the GTHA and doing case studies of actual as-built homes, which is the first large-scale benchmark study in the world. And so if we look at the NRCan study, the results for the two-story building, the worst model was 138 tons, the mid-range model was 30 tons, and the best conventional materials model was about 20 tons of storage. And of the buildings we've run, we're the way through these 100 homes in Toronto. Of the two-story results, right now, the worst case building in the GTHA has had 88 tons, and the best building has had 50 tons. So, interestingly, the worst case scenario isn't as bad as the NRCan study said, but the best case scenario is very, very far from what the best case scenario could be and was in that NRCan study. So, the as-built results in Toronto right now are sort of sitting, very much in the middle of the sort of worst to moderate range from the NRCan study. So I think that tells us that, there's much that could be improved in terms of fixing the emissions profile of homes in this particular region. In terms of how that material carbon emissions breaks down per kind of material category, we're just finishing up a study with the cities of Nelson and Castlegar in British Columbia, and their results are looking very much like the results from Toronto, but I have a complete data set there, so I'm going to share that with you. And you can see that the biggest share of material emissions come from the concrete that's being used in these buildings. Insulation is the next biggest category, with cladding and windows not that far behind. Interior surfaces, so that includes flooring, wall coverings, and ceilings, is about 10%. And the framing, the structural framing of the building is about another 10%. And roofing, not that significant, at 2.5%. And then structural elements are things like steel posts and beams and timber structures that are used structurally within the building, and they don't show up much at all. So, really we have concrete, insulation, and cladding as the categories that have the biggest impact, and where all of us collectively could be making the biggest impact in terms of driving reductions. Windows, that are a fairly big contributor, they're tough to make a difference. It doesn't really matter what kind of window framing material you use or the brand of window. Most of the emissions from windows are from making the glass, and all glass has pretty much the same emissions profile right now. So there's not much we can do to drive windows down, but there's a lot we can do to drive down concrete, insulation, and cladding results. So I just wanted to kind of put the NRCan results in front of you with both the materials emissions and their operating emissions together, just to sort of give you a sense that this is always the same house. Like this 2-story home, it always has the same size, the same windows, the same, like all the same features. It has the same degree of energy efficiency. It just has a different material palette to get there. And so you can see sort of proportionally, natural gas makes a big difference when we can keep the same building here, this red building, we keep the materials the same, we just go from gas to cleaner electricity, and that makes a big difference. Same thing happens here with this blue building, the materials stay the same, we go from gas to clean electricity, and sort of so on down the line. So, the potential results that, we could collectively be achieving could be anywhere on this spectrum. And so, obviously what we want to do is try to drive it towards the right-hand side of these results. Now, this is something that we haven't studied yet, but I would really like to. And if anybody is interested in sort of partnering on a retrofit study, it's something that our team would love to do, because as incentives come along for retrofits, the same thing is going to happen in the retrofit space as I'm pointing out here in the new construction space, which is if we retrofit with especially insulation materials that have a really high carbon footprint, the emissions from the materials may very likely outweigh the emissions reduction savings from the operations through a 20 to 30-year window, so that actually the retrofit that was supposed to reduce the impact on the climate could actually make it worse. And I'm seeing a lot of these renovations starting to happen here in Peterborough, where I am, and I'm sure they're happening everywhere. And to me, this is a red flag that we really, really, really have to react to, because, the worst scenario is that we spend lots and lots of money and lots of time telling people to do something that we think is good, and then find out that we're having the opposite effect that we wanted. And I think it's also possible, to end up with a result where the material impacts of the retrofit just end up balancing out the emissions reductions that are achieved by doing that retrofit. And again, you spend a lot of money, and you may not over a 20-year period be doing worse for the climate, but you haven't actually done anything to help it. So I think it's really important that we keep our eye on the new buildings side of things, which is what the NRCan study is about. But the same things will hold true when it comes to retrofits, and maybe even more so, because sometimes these reductions are much harder won in a retrofit. You might not see the kinds of dramatic energy results or energy reductions, and therefore emission reductions from renovations as from new construction. So what we really want is for our retrofit programs to do the same thing. If ideally we can be retrofitting with very low carbon or even carbon storing insulation materials, then we're actually causing a carbon drawdown to start the project, and we've reduced the emissions for the building. And so now we're actually starting to have the kind of impact on the climate that we want these retrofit programs to have. Now I'm going to talk a little bit about the carbon drawdown side and the carbon storage in materials. It's maybe a little bit hard to wrap your head around, but basically, as I explained, if you have a plant-based material, and sometimes there are mineralization versions of carbon storing materials too, where carbon has been drawn out of the atmosphere recently. And I guess I sort of say recently because the impact of wood and wood products is right now fairly uncertain, because in order to count the carbon storage in wood, we sort of have to know, does taking the tree out of the forest have a net positive or a net negative impact on the climate? And we don't know that for wood products right now. So here I'm talking about materials that come from either waste streams from our recycling systems, or from forestry or agricultural residues. where that material was already both grown and harvested and was about to be returned to the atmosphere. That carbon was about to go back to the atmosphere, and instead we turned it into a building material and kept it out of the atmosphere. And what this graph, this is a sort of visualization of ton-year accounting, which is a way of sort of looking at the climate impact of carbon storage. What the ton-year accounting is showing us is that 1 ton of carbon emissions today has 46 ton years of damage if we look at it over a 100-year period. And so if we can store 1 ton of biogenic carbon for at least those 46 years, then that's the equivalent of drawing down a ton of carbon. So, the great thing about buildings is that, a 40 to 50 year residency of a material in a building, especially a structural material or an insulation material, is not an unusual thing to be able to achieve. So we can sort of see that there is, really meaningful impact on the climate of using carbon storing materials. And so if we use ton-year accounting, we can also account for materials that either have a shorter or longer residency in the building. So, if you have something, say, like a flooring product that might only last 20 years, then you could, if there's 100 tons of carbon in that material, but it's only in the building for 20 years, it's had the equivalent drawdown impact of 43 tons. If it's 100 tons and it's there for the 46 years, it's had the equivalent impact of drawing down 100 tons. And if it's there for longer, so in this case 80 years, it actually ends up with an impact bigger than the 100 tons that's stored in the building. And there's really interesting work going on both in Europe and the US now, where this type of carbon accounting is being used to develop carbon removal certificates in North America. Is the first one that's actually looking specifically at buildings and specifically at being able to offer carbon credits and therefore pay builders to store carbon in their buildings. Now, the subject of cost always comes up. How much is it going to cost to make one of these low carbon or carbon storing buildings? And this is something that I would like to study more. But what we found in the NRCan study was that there was no direct correlation between cost and the material carbon impact of materials. So sometimes the lowest cost material also had the best carbon footprint. Sometimes the highest cost had the highest carbon footprint. Sometimes the opposite could be true, or the results could sort of fall anywhere in between. So it's not to say that the zero carbon building is going to cost less or cost more. It's to say it won't necessarily cost less or cost more. And this is something that in our own practice here at the Endeavor Center, we found that we've been able to do carbon storing buildings at market rates. And I think in discussions with builders, it's certainly something that that's not necessarily going to cost a lot, and certainly doesn't have some of the same cost impacts that making buildings much more energy efficient often have. So there's other sort of interesting stacked benefits of these low carbon building materials. One is that when I looked at the ingredients of all of the materials in the study, I found that the low carbon and carbon storing materials in every single category, not a single material I looked at contained red list chemicals or chemicals of concern. So, a move to this kind of material palette also means that we're going to be improving occupant health and safety inside the buildings. Again, with waste, the waste stream doesn't have to absorb any of the chemicals that are embedded in those materials. And interesting for regional and provincial governments, these materials all have local sources. The fibers for most of these materials come right from our regional recycling streams and our agriculture and forestry residues. So there's an abundance of the sort of raw materials to make these building products out of, right here in Ontario and all around the GTHA. and also potential for local manufacturing, because in a lot of cases, you would ideally be using local raw materials to make local low carbon building materials that are then used in local buildings, and sort of be building a stronger supply chain that involves local manufacturing as well as construction. And then I'm just going to finish up with some thoughts on things that municipalities could be doing to help move this along. Right now, I'm working with the cities of Nelson and Castlegar in BC on figuring out some incentive programs that they're going to offer, and I'm starting to do that with Vancouver later this month. So some of these things are already starting to show up in some Canadian municipalities, but things that we've talked about with Nelson and Castlegar are no cost things like simply awards and or recognition for builders who are achieving very low carbon, making sure that they're getting some marketing and some public visibility out of their efforts to make really low carbon buildings. Education, the kind of webinar you're at right now, if people within your municipality can become familiar with this topic and begin to sort of raise awareness of material carbon emissions in the local sort of building and design community and among your citizens, I think that would be really helpful. And then there are sort of more direct approaches like incentives for low carbon buildings. So in Nelson and Castlegar, we're talking about sort of a tiered approach where they set up some targets for material carbon emissions and sort of reward builders either with money or with permitting preference for meeting those thresholds. And then also, letting the province and the federal government know at the code level that your municipality would like to start thinking about this, and so that means that they need to start thinking about how material carbon emissions might show up in the code itself. And so that's it for the formal part of the presentation, and I'm now sort of looking forward to and glad to be able to take people's questions and have a bit of a discussion.
Perfect. Thanks so much, Chris. Really appreciate that. So we do have a number of questions. Just speaking to, I'll go to some of the kind of more easier ones first before we get into the deeper discussion ones. But with regards to the access to products, or how easy it is to identify those low embodied carbon or negative carbon products and the supply that is available, where are we right now in terms of the market availability of these products?
Right. The market availability of everything in the sort of high, moderate, and sort of best conventional materials models, so what I did in sort of red, blue, and yellow, all of that is stuff that builders are all using right now today. They're sort of, those were picked specifically to make sure that we weren't making models that were unbuildable. The only model where the materials don't show up regularly would be that green model. And there we said, no, what we want to do is identify what are the absolute best materials. And if they're not, they had to be something that we could find evidence that, buildings were built in Canada with those materials, but that they didn't have to necessarily be widely available. But otherwise, you can go to your local big box store and get everything that's in those first three models.
Perfect, thanks. And then out of curiosity, how do the embodied carbon, does it take climate resilience into consideration in any terms of kind of when you're looking at any of the analysis that you're doing, or is that outside of scope of the embodied carbon conversation?
No, I think the embodied carbon conversation needs to have just be part of the conversation. And so, nothing that was modeled in any of the models in this study has sort of any disadvantages in terms of it'll only last half the time, or, it'll, if it gets wet, it molds, or, they're all things that have really proven histories of being used in buildings in this climate. Even the ones that are less common, for example, that the green model with the great carbon storage, a lot of that carbon storage comes from having straw bale walls. Now that's not a really common approach, but we've documented 500 straw bale buildings in Canada. The first one is now almost 30 years old. So, it's an example of something that we're not doing widely. We could be doing widely, but it hasn't shown itself to have any disadvantages in terms of lifespan or durability or anything like that.
Okay, perfect. And then let me go into this question. So on that note, with regards to municipal, being able to bring this into their own decision making, either as they're doing work within their own facilities, or either in new builds or the retrofits that they're doing, or the retrofit programs that they're available, how might a municipality be able to advance embodied carbon considerations within the development community through either the use of like green standards, but also recognizing the limitations on the Ontario Building Code places on municipalities when it comes to above OBC requirements?
Yeah. That's a really good question, and I'm not a municipal policy person, so but on the sort of material side, the thing that I found really interesting is this is one of those cases where education makes a big difference. As I show these results, and when I'm talking to builders, I sort of break it down. They get to see what the results for different material categories are. That in itself is a game changer for a lot of people who had no idea that product A on the shelf and product B on the shelf that they treat as being more or less equal, this one has 4 times the carbon footprint of that one. So to some degree, it's just becoming aware of the numbers, has driven quite a few builders and developers that we started make really big changes, like being able to drop 10, 20 tons off a house from 3 material changes that cost them no money and didn't change anything about the construction of the house. It was just, oh, now that I know that this is different than that, I'll go for that. And so, there's a huge amount here of like the absolute lowest of low hanging fruit where, we can really get the buildings down to pretty close to a 0 carbon footprint with very little work. And then there's a bunch of work to, get below that line and really start to drive it down. But there's so much room for big movement in the low hanging fruit right now.
And that's great. That's good, really great information to have, because one of the things I did want to kind of highlight in the Green Development Standards work and legal authorities that we've been having discussions with the municipalities is that the municipalities, through their site plan control authorities, have every right to ask for whatever energy modeling report or any type of kind of checklist or any type of calculator submission. So in many ways, there's absolutely nothing stopping a municipality from requiring a development application that has gone through the kind of Builders for Climate Action calculator and submitted that as part of their full development application. So that would be something that's completely within municipal control. I mean, a municipality where we've kind of had the discussions with a lot of municipalities on this one is the municipalities have the authority to ask for any kind of report as part of a full development application. Where they might get into trouble, or actually where they probably would get into trouble, is if they withheld a building permit from a development because it didn't meet something above Ontario Building Code.
Yeah.
I don't have any, I've never had any experience with a municipality withholding a building permit for not meeting above Ontario Building Code requirements. In addition, I have heard a lot of cases where the buildings themselves don't meet Ontario Building Code requirements, and yet still a building permit is provided as part of it too. So I think that that's those are the 2 types of things we need to separate. What is required as part of a full development application, which is completely under the authority of municipal site plan controls, versus where is a municipality going to withhold a building permit for what reasons?
And I don't know all the sort of details policy wise, but I know, that the way the city of Vancouver has been working is they started with exactly what you said, just asking for the report, in order to file for I think it was for them on the planning side, not the building permit side, but in order to file, for a planning application, you had to do an embodied carbon analysis of the building, which allowed them to build up a database of what is normal, because that's been a question, like what's a good number and what's not a good number. I think that's something that we'll find. I'm really excited about finding that out with this study we're doing with the TAF funding. Vancouver had to wait for people to submit 100 plans before they knew what it looked like. We're going to go do that and have the results, by the end of this year. So, but understanding what the numbers are and where buildings right now are landing, I think is really important. But then Vancouver, has specified that they will achieve a 40% reduction in that number, but I don't know the mechanism that they're using to
Vancouver's a bit of an anomaly because they had a building code before the province had a building code. Okay. So City of Vancouver manages their own building code and are independent of the provincial building code.
That explains a lot
across Canada as a whole.
Yeah. So what we've been doing with Nelson and Castlegar is talking about, because I guess they don't have that. They've been talking about potential financial incentives, possible preferential treatment in terms of where you end up in the line for your permit. And again, I don't know what all the mechanisms that municipalities have to do, but I think there probably are some strings that could be pulled to at least entice. There's always the leaders, right? In the energy efficiency world, there's always a percentage who, when you tell them achieve this, like they go out and achieve that. And I think with the embodied carbon stuff right now, that's what we need. We need to just get those thought leaders, those building leaders to understand this part too, and to start showing what's possible. Nobody thought you could do a zero energy building until people did zero energy buildings. And it's like, oh, you can do that. And I think, we're basically looking to follow the same trajectory as the energy efficiency world has done, but now looking at materials and putting the two together so that, it makes sense.
And I think that's a lot faster than we took for the operational stuff.
Hopefully, right? Yeah.
How does this relate, like in terms of the ICI sector? I know your focus has largely been on the residential low-rise sector, but in terms of being able to kind of take this and move it to the ICI sector, how might that kind of, like, how would you factor that in, or what's the similarities or differences?
Yeah. I mean, the biggest difference is that in the sort of, and I guess I would count low-rise ICI buildings in this too, maybe, but low-rise buildings need much less of the really problematic materials. Like the really high carbon materials are concrete, steel, and glass. And so, in the residential world, there's a lot of concrete in foundations, but there's ways to sort of mitigate that. But you're typically not relying on those high carbon materials for a huge percentage of the building's structure and enclosure. Whereas, like, basically the bigger the building gets, the more of those high carbon materials you're relying on. And so it gets harder to bring those numbers down. There's a separate TAF funded study going on right now for Part 3 buildings. It's kind of the twin to the study that we're doing. So, they will be providing the same kind of, data set of, multiple buildings in the Toronto region. But I think, what we're likely to find there is that those really high emission materials are in those buildings in high quantities, and it's a bit of a harder game to get it, to bring those down. Whereas in residential buildings, the structure has a pretty low carbon footprint because it's almost all wood, and the insulation materials and the cladding materials are a much higher percentage of the overall volume of materials in the building. And that's where, especially in the insulation side, a lot of the real wins are. And so if you can use a simple insulation like cellulose insulation in the attic and walls of a house, you can offset half the carbon footprint of the house just with that, with that one move. Whereas cellulose insulation, and the amount you'd actually end up using in, say, a large tower is pretty small and wouldn't have the same sort of offsetting thing. So I think, the part 9 space is going to be the easiest one to achieve really big results really quickly. And hopefully, as the solutions and more materials and different ways of using the materials get applied in that space, they'll also migrate, kind of up into the larger buildings.
And then based on that, notice like a lot of municipalities right now are advancing retrofit programs, and municipalities have complete control over what will be eligible materials or eligible measures. So if you were to give some advice to municipalities developing their retrofit programs, what eligible materials should not be part of their home retrofit programs?
I try to be material agnostic, because I think as soon as we get into banning materials, we also then stop innovation sometimes in that material category. No material necessarily has to have a huge carbon footprint. You can produce the same material in 2 different factories with 2 different processes and get wildly different carbon footprints. So I would stay away from that. But what I would think would be a really good thing to do for those retrofit programs is to be combining, what, you're probably already trying to have an energy model done to say these interventions we're doing are going to have this impact on the energy use and therefore emissions. Add materials to that, in the same way I did in this study. Like, it has to be the combination of material emissions and operational savings, and make sure there's a net positive result out the other side. Because I think the last thing we want to do is spend a lot of money making the climate worse. And I have a real fear that that's where a lot of these incentive programs, that's going to be the result, because we've kind of turned a blind eye to what could be a really significant source of. And so, not many materials, but setting targets and making sure that the combination of materials and efficiency give the municipality the result that they're intending to have, and not the opposite.
And is there plans, let's say, because a lot of these retrofit programs are going to require pre and post NRCan audits. Is there work taking place for NRCan auditors to be trained on embodied carbon as part of their overall kind of curriculum?
Yeah, there's been some discussion about that. NRCan sort of had a proposal out recently for groups to look at training, and we were approached by a few of those organizations to bring embodied carbon into that training. So I don't know if it'll happen quickly, but that, it is starting to be talked about, and I'm really hoping to spend a lot of my time really trying to focus on that retrofit side of things, because I think it's where we're going to see a lot of movement soon as these incentives come in, and I just get so worried that we're going to do the wrong thing in trying to do the right thing.
Yeah. And I was thinking there's a lot of opportunities for training, because in addition, while we're waiting for NRCan auditors to kind of go where they need to go, there's the opportunity as well for municipalities to education in the municipal realm who's advancing these programs. And then in addition, there's education that can be done for a lot of municipalities are advancing energy coaches that would do a lot more hand-holding of their customers as they're going through a retrofit program. And that's a very easy opportunity for that education on embodied carbon to come into the decision-making on the homeowner's side.
Yeah, and if you are already sort of in the energy sort of auditing or advice space, like using this NRCan tool to figure out material emissions, it's easy. It's really, it's a pretty low bar for somebody to understand, and to actually use it. The NRCan tool will be sort of like publicly available. They're hoping by November, and so it's kind of I think a real no-brainer to make sure that anybody involved in those programs, again, even if there's no requirements, sometimes just knowing and having access to the numbers, you would recommend something different if you knew what the climate impact was going to be of those choices.
Yeah. And then in terms of the carbon storing materials and again, and kind of sequestering that carbon during the time period, with regards to life cycle and what happens when these products go to, or these materials end up with the disposal, would that eventually, I mean, that would eventually create that carbon taking place? Or is there thinking that this could be a kind of carbon storage over the longer term as well, not just the lifetime that it exists within that building?
Yeah, I mean, ideally it would be extendable, you know, and I think it's extendable in a few ways. One is, I think we make some pretty unfair assumptions about lifespan of buildings in terms of, you know, in a life cycle assessment, you're typically choosing a window between 40 to 60 years, but most buildings actually are around for a lot longer than that. And you know, the interesting thing, like if you think about the climate from that ton year accounting point of view, at the end of that 46-ish year period, if there's an emission from that material again, it's a new emission. Like it did the work of offsetting the tons that it offset for that period of time. If we can figure out ways to, you know, make these materials in a more sort of design for disassembly kind of way, like if you think about the sort of energy strong way of doing retrofits of buildings, you're putting on a panel on the outside of the building that you could just as easily take off and go put on another building later. I think that thing is really important. But also that when that carbon is stored in the built environment, one of the great things about that is municipalities know when buildings get taken down. You know, there's no like, if there is a fire, we know what happened. If there's a demolition, we know what happened. And it's also easy to sort of impose conditions on the demolition of buildings 30, 40 years down the road where you're responsible for the carbon in that building. And that could be sending it to a biochar facility, you know, reusing it. I think there's a lot of interventions we could make to make sure that carbon storage extends. But I think it's so important that we get the carbon out of the atmosphere now, and not blindly, but you know that there's work we need to do 40 or 50 years down the way to make sure there's not a sort of secondary burst of emissions. But a secondary burst of emissions in 50 years, if the climate's in okay shape, is a better problem to have than where we are now. I
kind of joke around, it's like present Gabby problem versus a future Gabby problem.
Yeah. Yeah, and I think, you know, if we're wise about it, we can, you know, be thinking and understanding that we need to be responsible with that stored carbon right now, but that nobody's going to actually have to take that action for, you know, a few decades.
So and that's what it really thinks. Like I know what I was quite shocked when I saw the numbers when we first came into it, that embodied carbon was just as important, if not more important, than operational savings. It's just that we actually know a lot more about how to run the operations than we had the information that we can bring in with embodied carbon. So thank you so much for all the work you've been doing on really kind of creating, shining a light or turning over some rocks and trying to figure out like, how do we bring this into our decision making? On that note. So I thank you so much. And I did want to leave time for you to share a little bit on the Embark project and where that's at.
Yeah, so we're really close to having run all the inputs for the 100 buildings that we're doing. And it's been great because the developers who've contributed plans to the study, you know, we're looking at 100 actual plan sets, but I think it actually represents closer to 900, you know, actual buildings in the region. So it's a pretty good sized sample. Everything's been built within the last couple of years, so it's a sort of really good snapshot of where things are at, sort of right here and now. And so we'll have the results really soon, and our sort of report will be out before the end of the year. So we'll be, you know, essentially talking about the same sorts of things as in this NRCan report, but very Toronto specific and very much based on actual as-built homes here.
And then thank you so much for this, Chris. Really appreciate it. We will probably come back to nag you in January to come back and to share the Embark results as well.
Yeah.
And I want to thank all the municipalities. I know that we've been nagging you to get some of the data from your development applications over the last number of years, and you've done such a fabulous job on providing some of that information. So thank you so much for that. It's all leading into the Embark project, and we'll come back to you in a kind of much more concise and easy way to bring into decision making than it was in the raw data. So thank you so much, Chris, for joining us and for giving us this tour of the NRCan report and the results of it. And a little bit of a teaser for the Embark project. Really appreciate it.
And if anybody wants to read the whole NRCan report, it's downloadable for free on our buildersforclimateaction.org website, so it's pretty easy to find there.
Perfect. And I'll make sure it's to live that when I send you, I'll send everybody the PDF of the presentation that Chris shared with you. We'll also send you the recording so you can share that with others in your municipality or your community who you think this would be great, who are interested or should be interested in this. And if you have any questions or follow up, please just get back to us and let us know. And I also wanted to kind of highlight, we will be, I'm going to be, I don't know if I did share that. I'm going to also share as part of what I'm going to also do actually in the proceedings that I'll send out to everybody is I'm going to share a survey where for the Ryan Zizzo from I'm trying to remember now if it's Manifest. I think it's Manifest or
Mantle.
Thank you. Thank you. Mantle. So I'll send that information because they are doing a study right now for not for low rise, but for high rise MERB and ICI, looking at those who has taken embodied carbon into their decision making and how they've gone about it. So I'm going to send out that as part of the proceedings as well, so that you can get that information. And then we will get them to kind of come at a future date when they have more findings from their work that they've done to share the story of how they're bringing the embodied carbon conversation into more higher rise types of developments. So Chris, again, thank you. Thank you to all of you for joining us. And I will send you all an email with the PDF, the presentation, and the link to the report so that you have it all and you can share it with others in your municipality and your community. In the meantime, have a great day. And thank you again, Chris. Really appreciate that.
Yeah, my pleasure. Bye-bye.
All right. Have a good one.